Okay, good morning all. Can you
Good
hear?
morning, sir.
Okay, are you able to see the slides?
Yes,
Yes,
sir.
sir.
Okay, so today we will start this course, that is ECE3007 control systems. Okay, so today basically we will be looking into what is a control system, and then I will give you a review of Laplace transform. That is the lesson that I have planned. So we will start with this question. What is 1 minute? I have bolded. Bolded how many? Four. Only one bolded. One bolded. One bold and all others. And the theory. Theory will be handled by bolded factor. One fellow got five section. I will show you. No, you will come to me later. I will show you. No, come to me after. Okay, sorry for that. Okay, so we will start with what is a control system. Okay, so now I will give you an introduction to control system based on one example. Okay, suppose you have a container like this. Okay. So in refineries and all, there will be big containers in which some chemical reaction and all will be happening. Okay, so one such container, a big container is there. It is filled with some fluid. Okay, so now two fluids are coming and mixing together in this. That is what the reaction is happening. So this is fluid one. Okay, so one fluid is coming inside to the tank, and another fluid is coming inside like this, fluid two. Okay, now these two are getting mixed and some at some particular temperature or something, and then some product is being developed. That is the purpose of this particular reactor. Okay, so you have a container in which two fluid inputs are coming and they are mixing together at getting mixed together at such particular temperature, and some fluid out. Okay, which is our product is coming out. So suppose I have written here, consider the tank shown wherein two fluids are getting mixed. So my objective, okay, so my objective is to maintain the temperature inside the tank at a constant temperature. Why? Because, okay, suppose these two fluids are coming and it will react together at a particular temperature only. So what I want is I want the temperature inside the tank to be at a particular constant temperature. Say for example, 100 degrees Celsius. I want the temperature inside to be 100 degrees Celsius. Then only the reaction will happen and you will get the desired output. Okay. So how will we do it? Can anyone suggest what is to be done first? First, what will you do? Any idea? Any idea? What will you do first? You understood the objective, right? Two fluids are coming, it is getting mixed together at a particular temperature, and then output is produced. The output will be produced only if the temperature is at a particular temperature. So my objective is to maintain the temperature inside the tank at a constant temperature. So what is to be done first? First, what will you do? Any idea? Anyone? Please unmute yourself and tell anybody who is having any idea.
Container should be empty.
No, container is full. It is both fluids are coming, have come. What is
To
to be
find
done?
the temperature of the container.
Correct. First, you have to measure. First, you have to know what is the temperature. Correct. Then only I can control it. So whatever you told is correct. First, we have to measure the temperature. So first, I should know what is the current temperature inside the tank. So for that, what will I do? I will use a temperature measurement system. So I am going to measure the temperature inside the tank using a temperature measurement system, which you might have studied in your measuring and instrument sensors class. So temperature is measured, and then this temperature. Now, can you tell me what will be done? First, I'm measuring the temperature. So now I know what is the temperature inside. Let it be Tm. Now what will be done? After measuring temperature, what should be done? I want the temperature to be at, say, 100 degrees Celsius. So what will I do first? Suppose this is Tm, measured temperature is only 70 degrees Celsius. I want the temperature to be 100 degrees Celsius. So what is to be done first after this?
Increase it to 100.
Increasing.
But before that, I should know whether it is more or less, right? So what has to be done?
Check it is our required
Check how
temperature or not.
so I will compare the measured temperature with the desired temperature. Okay, so you have desired temperature TD. So I will compare the measured temperature with the desired temperature. Is it clear?
Yes,
Yes,
sir.
sir.
Okay, so that will produce an error, correct? If the error is positive, what does that mean? If error is positive, what
More.
is that? Which is more?
It's a temperature is more, sir.
If the error, okay, so this is the error, correct? TD minus TM. So if error is positive, what does that mean?
Desired temperature is more.
Desired temperature is more, correct? Desired temperature is more than the measured temperature. So now what will I do is I will give this error to a controller. Okay, now this controller will decide whether to switch on the heater or not. Is it clear? So if the error is positive, what will the controller do? Will it switch on the heater or switch off the heater?
Switch off.
If the error is positive, what will be done? Error is positive means
Switch
which?
on.
Switch on.
Switch on.
Because correct. So error is positive means desired temperature is more than the measured temperature, which means that I have to give more heat to the liquid. Then only it will reach the desired temperature. Correct. So heater should be on. If the error is negative, what has to be done?
Switch off the heater.
Heater has to be switched off. Okay. So this is a very basic control system, which is known as on-off control system. Okay, you will either switch on the heater or switch off the heater. Okay. In every house, your house, there will be something like this. What is that? Can you tell me? One instrument which works on-off. Any example can you give?
Water heater.
Water heater, then
AC.
AC. Basic thing. Which one is it?
Geyser.
Geyser is water heater only, na?
Iron box.
Iron box.
Iron box. Okay, iron box uses this principle. This iron box was the first thing to use this principle, that is on off. Okay, once it reaches that particular temperature, it will switch off. You might be seeing the light is on off, light on off. Yeah. So I hope you got an idea about control systems. What is control system? Is it you got an idea, right? Any doubt
Yes,
in
sir.
this? Okay. Now this I am going to represent using a block diagram. Okay. So block diagram, it will have a process. That process is to be controlled. Say for example, in our earlier example, it was the temperature inside the the mixing process, correct? Mixing of two fluids, that was the process. So you will have a process that I am drawing as a block. Okay. Now that block, that will have different disturbances. What are the disturbances? The fluids 1 and 2 are coming, correct? And then the air outside temperature also is a disturbance. Fluids 1 and 2, their temperature might be varying. So that also is a disturbance to the process, correct? F1 is coming, F2 is coming. That is a disturbance to the process. Now it will produce an output controlled, which is known as the controlled variable. What was the controlled variable in the earlier example? What variable was controlled there?
Heat, temperature.
Temperature. So that is what is called as the controlled variable, the variable which is to be controlled. Okay, controlled variable means the variable which is to be controlled to a particular level. So that is the temperature. You are correct. Now, what will I do? I will measure the controlled variable, correct? I will measure the controlled variable. So from this line, I am taking, where will it go? To what instrument will it go? I'm connecting here. What instrument will it go to? To a any idea?
Measuring instrument.
Measuring, correct. Measuring instrument. So it will go to a measuring instrument. In our case, it might be a temperature measuring instrument like thermistor, thermocouple, or RTD, all those things. Okay. Then what will you do with this?
Checking.
It will be compared with the desired value of controlled variable. Correct. It will be compared with the desired value of controlled variable. Then error will be produced. That error will be given to what?
Controller.
Correct. Controller. The controller will be given to a what? Earlier example, what was the controller connected to?
Heater.
Heater. So that is what is called as the final control element. Okay. Final control element, and final control element will do the required thing on the process, and you will get the desired control. Is it clear, the block diagram?
Yes, sir.
Yes, sir.
Okay. Now definition. So now we will come to the definition of control system. So control system means it is an interconnection of components forming a system configuration that will provide a desired system response. Okay. Control system is an interconnection of components forming a system configuration that will provide a desired system response. So you can see that there are many subsystems, correct? There was a measuring instrument, there is a controller, there is a final control element, there is a process. So everything together forms a control system. What is the objective of the control system? It is to provide a desired system response. I want the output at the temperature to be at 100 degrees Celsius. That is my desired system response. Understood? More detailed, I will tell. Okay, I want the temperature to reach 100 degrees Celsius as quickly as possible. So that is a desired system response. I will tell I want the temperature to reach 100 degrees Celsius without much fluctuations. That is a desired system response. So please note that a control system is a interconnection of components forming a system configuration that will provide a desired system response. Now, a process or a component can be controlled, can be represented by a block. Okay. So this is the process. Okay. So this is the input and this is the output. Okay. So process to be controlled. to provide an output signal. So this input-output relationship, okay, that is what is actually known as the transfer function. We will come to that later on. Okay. Now there are two types of control systems. Okay, open loop control system and closed loop control system. Okay, so open loop control system means you will have a process. Okay. Now desired output will be there. It will be given to a controller, and controller final actuator or the final control element will be there. This is the open loop control system. You can see that there is no closed loop or there is no feedback. Okay, that is what is meant by open loop control system. You have a controller, actuator, process. That's all. Okay, so this is an open loop control system. Closed loop control system is what we learned just now. Okay, you will have a feedback. I'm not going into detail because it is the same thing. So here you can see that you are actually measuring the controlled variable and checking whether it has reached the desired value. Okay, so that is what is meant by closed loop control system. Is it clear? The difference between open loop control system and closed loop control system?
Yes, sir.
Yes, sir.
Okay. So in open loop control system, there is no guarantee that it will reach the desired temperature. Understood. Whereas in a closed loop control system, there is a guarantee. We ensure that it reaches the desired temperature. In open loop, we will go, if I give fluid 1 at temperature 20 and fluid 2 at temperature 40, they will combine together. Due to the reaction, the temperature inside will become 100 degrees Celsius. That is what we are assuming. Understood. Fluid 1 is coming at 20 degrees Celsius, fluid 2 constant at 40 degrees Celsius. If I am giving, okay, then the temperature inside will become 100 degrees Celsius is my assumption. That is what is known as a open loop control system. But we don't know whether it has reached 100 degrees Celsius or not. It might reach, correct? It might reach, but in closed loop control system, we are ensuring that whether the temperature is reaching that required 100 degrees Celsius or not. Clear? Okay, now we'll quickly go to the review of Laplace transform. Okay. So please remember all these things. What is the definition of Laplace transform? The mathematical equation. Please tell me. What is Laplace transform of x of t? What is the definition? Nobody reviewed. Okay. So this is the definition. I hope you remember capital X will be used in S domain and small x will be used in time domain. And Laplace transform L will be used for Laplace transform of x of t. This you remember, right? X of S is equal to Laplace transform of x of t. Now the formula is this: integral minus infinity to infinity x of t e to the power minus st dt. Please write these things onto your notebook. Laplace transform is defined as x of s is equal to integral minus infinity to infinity x of t e to the power minus st dt. Is it clear? Capital X of S, which is the Laplace transform of x of t, is equal to integral minus infinity to infinity x of t e to the power minus st dt. Okay. Now we will look into some standard test inputs. Okay. So I know that you guys have studied this in signals and systems and all. So I'm just brushing up. Okay. Can you define what is a unit step input or unit step signal? Can you tell me definition?
Having signal value 1.
One, when will it have signal value 1? When will it have value 1? Any idea? Okay, so unit step signal or unit step input is equal to 1 when t is greater than or equal to 0, and it is equal to 0 when t is less than 0. Please remember that unit step signal is defined as u of t is equal to 1 when time t is greater than or equal to 0, and u of t is equal to 0 when time t is less than 0. Do you remember this? You might have studied in your signals class.
Yes, sir.
Okay, so please remember this. This is a very important test signal. Okay, that is unit step signal or unit step input. Okay, it is equal to 1 when t is greater than or equal to 0, and it is equal to 0 when t is less than 0. So it can be graphically represented like this, correct? When t, so x-axis you can see t. Okay, when t is less than 0, value is 0. You can see the blue line. When t is greater than or equal to 0, value is 1. Clear? That is why it is called a step. You can see one step, correct? Sudden step. That is why it is called a unit step. Unit step means magnitude is 1. Okay. So you can see here from 0 to 1, there is a step. That is why it is called a unit step signal. Okay. Now, can you find out the Laplace? Do you remember what is the Laplace transform of unit step signal? Do you remember? Do you remember? No. Okay, we will find out using this formula. Okay, so x of s is equal to integral minus infinity to infinity x of t e to the power minus st dt. So what will I do? I will substitute. Okay, so instead of x, it is u. That's all. Correct. So u of s will be equal to integral minus infinity to infinity u of t e to the power minus st dt. Now t is varying from minus infinity to infinity. Correct. But what is the value of u of t? Between minus infinity and 0, what is the value of u of t?
Minus infinity to 0, it is 0.
Correct.
0.
And
0 to
from
infinity is 1.
so I can split this integral. Correct. I can split this integral like this. Minus infinity to 0, value is 0 e to the power st e to the power minus st dt plus integral 0 to infinity 1 e to the power minus st dt. Is it clear?
Yes, sir.
Yes, sir.
Okay. Okay. So what will happen? You will get what is the integral of e to the power minus st? Integral of e to the power minus st. What is the integral of e to the power minus st? E to the power minus st. Only that much.
Divided by
minus
minus
1.
s.
Divided by
Minus
minus
s.
s. Correct. It will be integral, sorry, e to the power minus st divided by minus s between the limit 0 and infinity. So now if I substitute the value of t infinity, what will happen? What is e to the power minus infinity?
0.
0. Correct. And what is the e power 0?
1.
1. So I will get like this. Correct. Minus 1 by s into e power minus s infinity minus e power minus s 0. So as you guys told, it is minus 1 by s into 0 minus 1, which is 1 by s. So please remember, Laplace transform of unit step signal is 1 s. Any doubt in this?
No, sir.
Okay.
No, sir.
Okay. So please remember this. Okay. always remember the definition of unit step signal and the Laplace transform. No need to know how you got the answer U of S. Okay, only the final answer you should remember. Okay, you should know what is unit step signal and you should know what is the Laplace transform of unit step signal. Okay. Now another important test input is unit ramp signal. Okay, so unit ramp signal is defined as R of t is equal to t when t is greater than or equal to 0. And it is equal to 0 when t is less than 0. Clear? So graphically, I can represent it like this. Correct? When t is less than 0, value is 0. Blue line you can see. When t is greater than or equal to 0, it is equal to t, which means that when t is 0, value is 0. When t is 1, value is 1. When t is 2, value is 2. When t is 3, value is 3. When t is 5, value is 5, and so on. So it will be a straight line like this. Is it clear? Because
Yes.
R of t is equal to t. Okay. So whatever t, so suppose if t is 5, what will be R of 5?
5.
5. R of 10 will be 10, like that. Understood. So whatever the value of time is, same value will be the input signal. Okay, so Laplace transform of unit ramp signal also you can find out. Okay, I have given this. You can you have to use integration by parts. I hope you remember that. Okay, so I have done this. You can go through it. Can you guess what is the Laplace transform of ramp? Final answer, what is it? One by
Minus 1 by s?
no, 1
Minus
by
1
s
by
square. 1 by s square. Okay, you will be getting 1 by s square. So please remember this also. Okay. Laplace transform of unit ramp signal is 1 by s square. Clear?
Yes, sir.
Then another signal is unit parabolic. Okay. So unit parabolic signal, oh sorry, here it should be t square by 2. I'll correct it now itself. Otherwise I'll forget. Sorry for that. Okay, unit parabolic signal is defined as R of t is equal to t square by 2 when t is greater than or equal to 0, and it is 0 when t is less than 0. So this is the pictorial representation of R of the unit parabolic signal. Okay. Laplace transform will be 1 by s cube. Okay, so please remember that also. So Laplace transform of unit step signal is 1 by s. Laplace transform of unit ramp signal is 1 by s square. Laplace transform of unit parabolic input is 1 by s cube. Okay. Now, one more important signal is the known as the unit impulse input. Okay. So unit impulse input is defined like this. It is equal to 0 when t is not equal to 0. Okay, it is denoted using del of t. Okay, so small delta is used. Small delta of t is equal to 0 when t is not equal to 0, which means that it has value only when t is equal to 0. Okay, at all other values, at all other time instance, the value is 0. So it is defined like this. Unit impulse signal is defined as del of t is equal to 0 when t is not equal to 0, and integral minus infinity to infinity del of t dt is 1. Okay, so this is the correct definition of unit impulse input. It is defined as del of t equal to 0 when t is not equal to 0, and integral minus infinity to infinity del of t dt is 1. Okay, so please remember this. Can you tell me what is the Laplace transform of unit impulse signal? What is the Laplace transform of unit impulse signal? Nobody. Okay, Laplace transform of unit impulse signal is 1. Okay. So please remember. Okay, so these things you should remember. Laplace transform of unit impulse signal is 1. Laplace transform of unit step. What is the Laplace transform of unit step signal?
1 by S.
1 by
1 by S, correct. Laplace transform of unit ramp signal?
1 by S square.
1 by S square, correct. What is the Laplace transform of unit parabolic signal?
1 by S cube.
One.
Okay. Now another thing is Laplace transform of e to the power minus alpha t u of t. Do you remember? What is the Laplace transform of exponential minus alpha t u of t? Okay, 1 by S plus alpha. Okay, please remember this. This is a very important Laplace transform pair. Laplace transform of exponential of minus alpha t u of t is 1 by S plus alpha. Okay, then some other standard pairs are this. Laplace transform of sine omega t u of t is omega by S square plus omega square. Laplace transform of cos omega t u of t is S by S square plus omega square. Laplace transform of e to the power minus alpha t sine omega t u of t is omega by S plus alpha the whole square plus omega square. Okay, so all these things please remember. Okay, this much standard Laplace transform formulas you should remember. Clear. If you don't know how to, one I will show, and we can how to do it. And I will show quickly and we can say, for example, Laplace transform of, you can see this, right?
Yes, sir.
Okay. Laplace transform of, I'm going to give the signal, that is, let it be x of t equal to e power minus alpha t q of t. Okay. Suppose I want to find the Laplace transform is. So what is the formula for Laplace transform? Laplace transform is defined as what? What is the formula? Can you tell me what is x of s? Equal to x of s is equal to, what is the formula?
Integration minus infinity to infinity.
Integral,
X
correct.
of minus infinity to infinity.
Then
X
here,
of t into e power minus s t dt.
okay, e power minus st dt. This is the formula, correct. So now what will I do? I will substitute for x of t. What is x of t? X of t is e power minus alpha t u of t, correct. So it will look like this. But what is unit step signal? What is the definition of unit step signal? What is u of t equal to?
U of t is equal to 1 when t greater than or equal to 0.
Correct. So it will become like this, correct? U of t is equal to, sorry, is equal to 1 when t is greater than or equal to 0. And it is 0 when t is less than
0.
So what will happen to this integral? what will happen to this integral? You can see that inside this integral, one u of t is there, correct? So what is the value of u of t when t is less than 0?
0.
So what will happen to this integral?
0.
0.
But final is it 0 everywhere? No, right?
No.
So what will happen to the limit? Can you tell me?
Minus infinity to 0 and 0 to infinity.
So minus infinity to 0, but minus infinity to 0, what is the value of u of t?
0.
0, correct?
0.
So I can write like this, correct?
Yes, sir.
Plus, now what will be the limit here?
0 to infinity.
So what is the value of u of t at this time?
1.
1.
1. So what will happen? Finally, this integral will become what?
0.
0. Finally, this will become only this, correct? 1 means it will be like this, correct? Are you getting the idea? Now I can combine these two, correct? E power minus st, e power minus s plus. So this can be written as s plus alpha, correct? Am I correct?
Yes, sir.
Now what is the integral of e power minus of s plus alpha t? Alpha is a constant, so tell me, what will it be?
E power minus of s plus alpha t divided by minus s plus alpha.
Correct. This divided by minus of s plus alpha. Is it clear?
Alpha.
Correct.
Yes, sir.
Between the limits,
Infinity to 0.
0 to infinity. Correct. Correct. So from this, I can take minus 1 by s plus alpha outside. Correct. So what will be inside the bracket? First will be e power what? When I substitute infinity, it will become e power
Minus infinity.
minus infinity. When I substitute 0, it will become e power
0.
0. So what is it? Minus 1 by s plus alpha. What is e power minus infinity?
0 minus 1.
0 minus 1. So what is the answer? Final answer?
1 by s plus alpha.
S plus alpha. That is what I have written there. Is it clear?
Yes, sir.
Okay, so that is, so for example, let us take an example. Suppose x of t is equal to, okay, suppose x of t is equal to e power minus 3t. Then what is x of s?
1 by s plus 3.
Correct, 1 by s plus 3. Okay, so this you can check in MATLAB also. I hope you guys know. Okay, I have opened MATLAB and okay, so it is very simple. Okay, what you have to do is first you have to write the define t as a symbolic variable. Okay, so that it is defined like this: sims t. Okay, which means that t will be defined as a symbolic variable. Now I am going to give x. X is equal to exponential of minus 3 into t. Correct. This is our symbol signal. Correct. Now let us find what is the Laplace transform. For that, one formula is the Laplace x. See, is it correct? Understood?
Yes, sir.
Okay. So whatever you want to do, you can check in MATLAB also. Suppose you want to find what is the Laplace transform of, okay, maybe small function I will give, sine 3t, 3 into t. Okay. So I want to find the Laplace transform. So Laplace of f. Can you guess what is the Laplace transform of sine 3t? what is a sine omega t? What is a Laplace transform? Sine omega t, Laplace transform is omega by s square plus omega square. So similarly, what will be the, what is omega here?
3 divided by s square plus 9.
Correct. 3 divided by s square plus 9. See here, 3 divided by s square plus 9. Understood. Suppose I had given cos. Can you tell me what will be the answer?
S divided by s square plus 3.
S divided by s square plus
9.
9. Oh, sorry. Sorry. S divided by s square plus 9. Is it clear? Any doubt? So please remember these much Laplace transform formulas. Okay, the pairs you should remember, so that it will be used in second unit. That is why I'm telling. How to find that inverse Laplace transform also you should learn. In between, whenever I get time, I will be teaching. If you don't know how to find the inverse Laplace transform, I will be telling you how to do. Now, in today's lecture, if you have any doubts, you can ask. 5 minutes is there. So if you have any doubts, please ask. So as I told, please study this much portions. Okay, today itself. If you have not written, copied it to the notes. Okay, copy it to your notes. Okay, right. Okay, otherwise you will not learn. Okay. This okay. This also I will upload in the slide. If you don't know, I will upload this also. Any doubts you have?
No, sir. Can you share course handout also, sir?
Course handout I have uploaded. No, let me check. I thought I uploaded. Your classroom is this, right? ECE2 control systems. I thought I uploaded. Let me check.
Uploaded, sir. Sorry.
It is uploaded. I have uploaded. Course handout you can see. Okay. Okay. Any doubt?